Hello and welcome to this course. In the previous videos, we addressed the series connection and the parallel connection separately, and we also performed some calculations for both types of circuits. In this video, we want to juxtapose the series and the parallel connection and perform some basic calculations in a comparative fashion. We have given a voltage source which provides 230 volts, and that's a common voltage in Western Europe in power lines. And we have 4 resistors, each of which have a resistance of 100 ohm. And what we are looking for is the equivalent resistance, the total current, and the electric power for an arrangement of the resistors in series and in parallel. And we're going to compute the values for both types of circuits, series and parallel. So let us begin with the equivalent resistance. I'm going to label the equivalent resistance as R subscript EQ and superscript S, which stands for series connection. And in this regard, when I say the equivalent resistance or the total resistance, I mean the same thing. So don't be confused by me switching between naming this the equivalent resistance and the total resistance. They're all the same thing. And for a series connection, the equivalent resistance can be computed by simply adding up the resistances of each resistor. In our example, we have 4 resistors with 100 ohm each, so 4 of them connected in series will give us 4 times 100 ohm, and whether you say ohm or ohms, the latter is actually plural and the former singular, but it doesn't make a big difference as far as correctness. 4 times 100 ohms is equal to 400 ohms. So that's the total resistance of the resistors connected in series. And for a parallel connection, I'm going to label R EQ superscript P, which refers to the parallel connection. And the formula for the equivalent resistance in the parallel connection is 1 over the sum of the inverses of the resistances. And in our case, since we have 4 resistors connected in parallel, the equation is going to be 4 divided by 100 ohms. And that is equal to 25 ohms. As you can see, there is a big difference between the equivalent resistance in a series connection and a parallel connection of 4 resistors, each one having 100 ohms. And now let's move on and calculate the electric power. Sorry, let's actually do it for the total current. Electric power is going to come next. In a series connection, the current is the same everywhere. So if I label it total current, that's actually the current that runs through every single resistor. And I'm going to put the superscript S. So to compute the current, we need to divide the source voltage by the equivalent resistance. And the source voltage is 230 volts divided by 400 ohms, and that is equal to 0.575 amps. For a parallel connection, the formula for the total current is identical. You need to know, though, that in a parallel connection, the total current is not the current running through each individual resistors. We had that in the video that dealt with the parallel connection. So we are computing the total current that is drawn from the voltage source. And as I said, the formula is the same. Voltage source divided by the equivalent resistance, and that's gonna be 230 volts divided by 25 ohms this time, and that gives us 9.2 amps. Again, quite a big difference between the currents. And finally, we're going to compute the electric power for the series connection, and that is US, the source voltage, times the total current, is equal to 230 volts times 0.575 amps is equal to 132.25 watt. And for the parallel connection, oh sorry, I forgot the superscript P for the current. Again, the formula is the same as in the series connection, but you plug in the current for the parallel connection, and that is equal to 230 volts times 9.2 amps, which is equal to 2116 watt. So these are the values of the variables that we're looking for, and if we compare the ratios of the variables, of each variable for a series connection and a parallel connection, we will notice that, for example, the total current, the ratio of the total current in a series connection and in the parallel connection is equivalent to 1/16. That means that the total current is 16 times as intense in the parallel connection as in the series connection. And for the power, it's the same if you compare this number and this number. So 1/16. Also, for the equivalent resistance, though, the ratio is reversed. So in a series connection, the equivalent resistance is 16 times as large as in the parallel connection. And this explains why the total current and the electric power in the parallel connection is 16 times as intense, because in the parallel connection the equivalent resistance is only 1/16 of the value in the series connection. That's it, folks. Thank you for watching and stay tuned.